Alright, brace yourselves. The time has come to talk about conditional statements and loops. Everything computers do is just a clever application of logic gates of different kinds on electrical currents representing numbers. On one end of the spectrum, you get basic calculators, and on the other, runtime engines with graphic user interfaces and virtualized chips running operating systems, and you can build a computer in Minecraft. That's like so many layers of abstraction right there. Conditional statements and loops are predicated on the fundamental semiconductive properties of silicon, and without them, computer science wouldn't exist. It's essential that you master conditional statements and loops to be able to make effective code. So to that end, let's see what they allow us to do. Conditional statements, that is how you tell computer to make decisions and behave in special ways in special situations. And loops allow you to repeat a certain function a bunch of times. Remember how previously when we drew a random point on the screen, let's make this one black. Let's make the screen white. So previously when we created a random point on the screen, we would copy this pset function and just repeat it a bunch of times. And then if we run it, bam, we have a white screen with a couple of black dots. But what if we wanted like 100 black dots? It would be really stupid for us to repeat this 100 times. So in those kinds of situations, what we do, we use a loop. Let's start with a for loop. For loop is the OG loop. It is the basic loop. For loop has three parts. It has a definition, so let's call this one start, and we're going to begin it at 0. So we're just defining a variable. We're saying keep cranking until this variable gets to a number, let's say 25, and increase every loop by 1. So this is a block of code that corresponds to a for loop. Just like our draw function draw is a block element that contains some code inside it. A loop is a block that contains its own functions inside of it. So again, good practice to open a loop, define the bits that make it up, write the do, because you can't have a loop without the for, and the do with a sort of loop definition on the inside, and then end at the end. So let's move this pset inside of our fresh loop. So now we're going to clear the screen, and we're going to create 25 dots. What if we wanted to create this many dots? Yep, totally doable. And all it took was typing some more numbers. How far can we take this? Oh, that's nice. It actually crawled there for a second trying to draw all the dots. That is a lot of dots. Because we're randomly drawing these dots, it is actually selecting certain random coordinates multiple times. So this is not the most optimized thing, but by and large it creates a nice little cloud of dots. All right, so that's a loop. That is the power of the loop. What can we do with this thing? Let's create a sort of a petri dish. These are our specs that we threw into the agar, and now we're gonna grow these guys into gnarly flex. So what we're gonna do is every frame of animation, we are going to randomly select a bunch of pixels, check to see if any of those pixels are of our color, black, and if they are, we're gonna grow them. So let's type that out. Let's do another for loop. For grab is equal to 0. Let's grab, I don't know, let's grab 20 pixels per frame. I think that's like plenty. And increase by 1, do end. So what are we going to do? 20 times we're going to do a pget. And we're going to pget from a random 128, random 128. So we're going to grab this pixel with pget. How does pget work? Where's our pget? Pget xy. Let's look at it. Pget xy. Get or set a color. Okay, well, I mean, that was unnecessary. So we're going to grab a color. I guess it returns a color of a specific pixel. So let's feed it into a variable, and I'm going to call it C. So now inside of this loop, where every single time that a pixel is grabbed on the screen, we're going to know its color. But this is not very helpful right now because we are feeding the x and y coordinate of this pixel into this function, and we don't know what they are. We're not saving them for any other application, which we will need if we want to like grow each pixel, because now we have to like, if it's a black pixel, like put more code in here. So what we're going to do is we are going to extract the x and the y. So I'm just going to grab this guy and put an x here and put a y here, and then make x equal to a random and y equal to a random number, right? So now we have the x and the y and the c. And notice how I'm using empty space, like just basically spaces, to indent things and make things more legible. Sometimes I will you know, add space between things, and sometimes I won't, because I don't know, there's only so many pixels on this screen and I want to make things look a little more compact. But it's really like up to you. Lua is very forgiving when it comes to white space. There's very little white space that means anything in the program. So you can put a bunch of things in one line if it makes sense for your internal organization or whatever. So all right, so now we're grabbing the x and y and the color. And you know, like these values, we don't really need them outside of this for loop. So to speed things up, because we're going to be doing this a lot of times per frame of animation, and we're going to be doing a lot of logic in there, I'm going to make these variables local by typing local in front of each of these. What this local means at this particular point is that this x belongs to this for loop. And outside of this for loop, this x does not exist. This will help free memory as we are crunching these things, so that the x and the y don't have to remain there. So it's a good practice to think of your scope. This is what's known as the scope, right? So like the scope of a like code block are all of the like the inside of that code block, cloud block, blah blah blah. The scope of a like container block of code is the inside thereof, right? And so this will help you clean up stuff. Like maybe we have some kind of an x over here, and we don't want to confuse which x we're talking about. We don't want to accidentally overwrite this global scope x with another x. That is another situation in which we can define a local x inside of a function, right? So for all of the purposes of all the calculations inside of this scope, you can safely use x, and it will refer to this random number and not to this x outside. If we needed to have this x inside of this for loop, but I don't know, maybe we were doing it later and we're just like, screw it, there's a lot of code in here, I don't want to retype all of that because I'm changing a variable. We can do something like this: local other x is equal to x. This is totally a valid thing to say because at this point, other x is what we can refer to this global x inside of our little scope. So that was a little scope aside. If you have questions, ask, as per always. So enough about that. Let's remove these. All right. So if it's a white pixel, we don't want it to grow. We only want it to grow if it's a black pixel. So let's put that logic in here. So let's do an if, and then write a condition. So if C is black, if C is black, then end. So now I've created a code block. Notice that I have 3 ends already at the end of this code, and that is why I keep saying, like, just close your blocks, because you're opening blocks inside of blocks, and it's a block inception, and you will forget how many ends you need to close this thing if you're just typing and opening things without closing them. And you're always working from the sort of like outside in, so you're like creating a block and then you're putting stuff inside it, and then you're creating a block and you're putting stuff inside it, and that is the organic way to code. That is why it's the best practice to add the ends from the get-go. All right, so if the color that we grabbed is 0, here we have the double equal sign. What is the double equal sign? The double equal sign is not the single equal sign, and it's super easy when you're coding and not thinking to accidentally put a single equal sign. Remember that the single equal sign is assignment. So what we're saying here is if C equals 0, we are like in the middle of what is supposed to be our condition. We are accidentally assigning that C is 0. So we're kind of breaking our own conditional statement here. Hopefully this will throw an error, so let's run it. Syntax error. Ah, that's so excellent. Lua is really nice. Other languages will maybe like decide that this is false and just like keep trucking, but Lua is really nice, so it's going to tell you when you've forgotten to make it a conditional. So double equal sign means check to see that this is true. You can also say things like C is bigger than 0. Maybe like we're going to use a whole bunch of different colors, and black is our neutral color, so we would check to see if our color is not black, right? Because like black is 0, so if the color is bigger than 0, it means it's one of these other numbers. But that's not what we want to check. We actually want to check if our color is not white. So let's code it like that. So this is how you would say if something is not. You use the tilde squiggly and equal. Some other programming languages use the exclamation mark to denote like not equal. So this means not equal, these two characters together. I think you can use the same thing in Lua. Can you use that in Lua? Not shorthand, but Pico-8 also accepts blam instead of blam for not equal to. Cool. Pico-8 is cool. As is Lua, even though it has this weird thing that no other programming language that I'm familiar with uses. Anyway, if C is not 7, then, like, if the color of our grabbed pixel is not white, then let's draw a circle. A filled circle at our XY coordinate. See, that's why we grabbed our XY before, so now we know. Filled circle and radius, let's just make it 1. And color black, of course. So let's see what this does. Run. All right. They're growing. They're growing really, really slow. So how do we make it grow faster, right? Right now we are running this with 20 grabs per frame. So let's increase this to 200 grabs per frame. So let's do run. So this is faster. Yeah, this is nice. They keep growing. They grow kind of fast. I feel like they could grow even faster than this. So alright, let's go with 500 per frame, 500 grabs per frame. So that's your introduction to conditional statements and loops. We can push this a little further though, but this is a good place to stop.